if you type in soil quality demonstrations on Google, you'll find the materials you also that you have for the 3 demonstrations I'm going to show you. You've got in your book in the section 5, so I'll have a copy of those up there. Also, I think Matt will probably get you that there's a soil quality. NRCS has a soil quality website overall that's got a lot of information for soil quality as well. Okay, we're going to start with soil water demonstration, and you've got a nice little lesson plan right here. What we're trying to demonstrate with this is that more water infiltrates into less disturbed soil, and then more water runs off soil that's disturbed. Understand the importance of infiltration to provide water for crop growth, right? The more water we can get into our soils, these are the same texture as soils, by the way, the more we're going to have for crop growth and production. Understand how undisturbed soils can reduce flooding, the amount of sediment, nutrients, and chemicals. So what happens when we get sediment runoff in our runoff water that gets into our streams and ponds? They're usually they're the highest in the nutrients such as phosphorus and some of the other nutrients that come with that. What I did here for this demonstration is this is from my farm in Nuckolls County, just northeast of Lawrence, a couple of miles. And this has been in continuous no-till for about 17 years, okay? And this year it was wheat stubble. We had corn. We've got corn growing there now, planted in the wheat stubble. So I took the residue off. This demonstration would be even better if I had residue on it, because what happens with the residue cover, you get rainfall, it deflects the raindrop. The amount of energy from rainfall is tremendous, especially on bare soil. This is, I'm not going to say where, but it's the same soil. They're both Selt loam soils, Holdridge Selt loams, or Hastings Selt loam, excuse me. And so this one was tilled. And the way I did this is these are just homemade, okay? And the information on basically what's contained in these, you could do this as a welding project in a shop. Most farmers are set up. These are stainless steel. I put these into the ground, got a tile spade under it basically, and then brought it in intact. So that's how I did it. And then I've rained on it several times, and you got to kind of seal the edges a little bit, because what can happen if you've got airspace around the edge. So what we're going to demonstrate here, and I'm going to get a couple, see, where's my Nuckolls County folks? Come on up here. And then I'll pick somebody that's close. Just come right on around me. Got to get skinny. I didn't say that. Yeah, take a step forward. Okay. You've got water. Be careful not to spill and cause all kinds of damage up here. There's a lot of equipment, so don't be nervous. Okay. Okay, so take your left hand right here, or whatever, depending on your right or left, whatever. Okay. And you're going to, basically what they're going to do is hold this up like this, fill this cup with water, and they're going to rain over this simulated field. I've got it on a slope. It's probably about an 8% slope. So you're going to rain across that surface, and you can move that back and forth. So make it rain across the whole surface, so you can move it back and forth. This is all homemade stuff, right, that you've got. So what it's going to do is basically show you how much is infiltrating either into the pan below or how much is running off. You may want to scoot that up so we don't, yeah. So what things is this showing you? Okay.
Runoff versus infiltration.
Runoff versus infiltration. Anything else that it's demonstrating for you? What was it?
Soil compaction.
Soil compaction. That initially when we started it was nice and loose. It was a disked field. What happens after the first half-inch rain? It did take it pretty good the first rain, but then it sealed up. Okay. You heard Charles talk about aggregate stability. Which one do you think has more aggregate stability? The one on the left, okay? That one's been tilled to death. And she can put this particular sample we took, we did a prescribed burn on my farm. I have some CRP and I had to do that this spring. So one of the soil scientists that's on our staff went ahead and did these. I had another one that was next to it that must have been on a wheel track, because what happened with that one is we did get runoff, but we didn't get the soil movement like you're seeing there, the amount of sediment. Okay. I'm going to grab this. So you probably rained enough, but you can see just take a look at what's happened there. Okay. Everything went in. So, and you can do this easily with your students. The other thing that I did, and we've got some of these, that those of you want to take some home, we built another one that's a little bit cheaper version. This is actually $3 worth of stuff. Henry got these plastic containers for $1 at Menards. He built the little the wood container. We got the screening on the bottom and a little plastic funnel basically for your runoff. A good little project. So there's another option, and I've got some over there that those of you that want to use it. Now she's going to keep raining. She wants to see if she can get runoff there. So this is in these fields. This one is in a corn, soybean, wheat rotation. So, and then this year we had some cover crops on that as well, just after the wheat harvest. So that's kind of what happened there. Just a couple of things. You could compare samples from several different management areas. You could have different management systems. To get kind of a good comparison, though, what you really need is similar soils. That's why I wanted to get soils with somewhat the same texture. If you allow the soils to dry for several days, you can run it again. What I've done here is I was pretty close to what's called field capacity of the soil, which means that all the free water has moved on out. So, but it's pretty close to full available soil water. You can take the soils out of the pans, mix them up again on the tilled. There's lots of different things. You can add residue. We've done these with range, where you have good roots and all of that. So you can do various things that way. The questions basically for the students is, and I'll ask you this, did both samples react the same way to addition of water? To rainfall? No, it's pretty obvious, right? So, as long as I have, and these are surface soil samples, what's going to do with this kind of infiltration is going to take it on down to my subsoil. Now, if you have a sandy soil, is it going to react the same way as if this was in no-till versus if this was in conventional till? What do you think, Paul? Paul's seen a lot of this. So, sandy soil just naturally doesn't have a lot of available water holding capacity, so you're not going to see near the difference. Also, if you take a look in this jar here, it's somewhat cloudy. What do you think that is that's in there? Why is it still cloudy? Sediment. What settles out first? Sands. What's second? Silts. And then lastly, clay. So the clay particles have much longer differential settlement, and sometimes some clays will stay almost suspended forever. If you see ponds that still are dirty, that's the clay that's still in there. Okay. Was runoff more clear in one jar or the other? We talked about that. If the water became cloudy, did it become clear again? It's getting a little bit more clear, right? So it is settling out. Okay. Which soil has more pores in it after a rainstorm? Okay, that's pretty obvious. And which one's more resistant to erosion? So the aggregate stability. So some really good basic questions. And we've done this where we've had 4 or 5 different examples. You add residue to this, that would be even better. Okay. And then to pass this around the second part of it, and I'm going to show you the same soil. This is the one that's from my same field that we got a little bit of runoff off. This is no-tilled for 17 years as well. But what we do with these samples is we just take a water and glue paste and paste around them, and then they stay intact. So what you want to do is take a look through this and look at the wormholes. Okay? So that's what's happening over here. Okay? And that's the same soil. I got a little bit of runoff. I think there's probably a little more compaction than there was on this one. Okay? And then I'll pass these around this way. Here's some more clay type soils. You can still see the holes in them. Okay? You can pass that one that way. Okay?
So how do you make those?
These were just put in we let these dry out, and then we just take a glue paste and water and glue and take a brush, a paint brush, and just basically paint all the way around. It keeps it intact so they don't crumble for you.
What kind of water is glue paste?
I think we just use Elmer's glue and water, yeah, and then mix it up and then paste it over top. A good little project. So this is a conventional till. I just handed those out. This is the same soil that's been conventionally tilled, and take a look at the difference in structure. It's just there's no pore space in this, and you can imagine those are pretty heavy clay soils. Okay, it's a brick. That's what you create. If you've ever been a kid and you created a mud pie, what's the first thing you do? That's what that is. This is a North Carolina soil. Henry moved to Lincoln from North Carolina. And this is a really much tougher soil to manage for than what you see here. But this was a no-till soil as well. And take a look at the bottom. This is the top. Still got the residue. It's got a lot of wormholes in there. So what you can do is actually add some demonstrations to kind of see what's going on somewhat inside of these soils. Okay? Okay? Okay, the next one we're going to do is called, this is soil water. This is soil glue. Okay? And anybody have any idea what soil glue is? What the heck? Why would you use a term like that? Makes the aggregate stability. Where does the soil glue come from? Microorganisms that especially organisms that like fungi that make proteins, and they make proteins such as what's called glomalin, and that's the soil glue that holds together. And what this is going to do is we're going to compare a soil like that block, that solid block that was tilled, and see how it holds together. Why would you think that a soil would fall apart when you put it in water and be more prone to erosion? What's happening physically there? The glue dissolves, but the glue's helping hold it together. So, right. So hold it together. But the soil itself, when we put some soil samples in these containers here, what happens is the water is absorbed and the internal pressure causes it to rupture. Okay? So that's what's happening. You get internal pressure. Does it have any aggregate stability, any soil glue to hold it together? Okay? And there's all kinds of benefits you've already seen here. So we can get a couple more volunteers here. Okay, I'll just pick on you guys. This is a no-till from my same field. This is a tilled, that other soil that I just passed around that was in a hard block. Just go ahead and place them gently in each one of those containers and we'll see what happens.